Okay. Well, first off, I'd like to start out by introducing myself. Hello, my name is Lance Zurich, and I am the product manager for the Fischer Technik Education Division over here at Studica. And today I'm going to provide you with an overview of Fischer Technik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, a college professor, or industrial trainer teaching programmable skills required in manufacturing, a company looking for ways to demonstrate their software-based solutions, or someone looking for ways to make IoT-related concepts easier to understand to employees or customers, I believe this presentation will offer some important options for you to consider. Let's start off by considering the skills gap. If you've attended any of our other Fischer Technik education webinars, you've probably heard me discuss the importance of STEM education. STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should go without saying that STEM education has become perhaps the most discussed topic in education for the last decade. As most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or grandparents were entering the workforce, employers in such areas as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers are now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. As it ties in directly with the solutions we will be looking at in this presentation, let's consider the last skill area I just mentioned, that of a PLC programmer. First off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. The term, essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in industrial settings, such as an automated manufacturing plant. Now, as the world of manufacturing becomes more increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. To get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programming salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $136,600 per year, end quote. In fact, a quick glance at the first page of current job openings for PLC programmers on Nuvu for the date February 27th of 2020 shows 15 positions being advertised with salaries over $75,000, two of which list salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. At the same time as this workforce of tomorrow gets their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take? Well, depending on a student's background and experience, very basic programming skills can be learned in as little as 30 to 40 hours of training. Of course, to be truly proficient in all 5 of the most widely used PLC programming languages, such as you see listed here, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, more training would of course be required. We of course see the 5 most popular programming languages listed here, which are ladder diagram or LD, sequential function charts or SFC, function block diagram FBD, structured text, XST, and instruction list, IL. Now, once again, while many students can learn programming skills in a college lab setting, there are many other options available as well. There's high school CTE, career and technical education programs, adult continuing ed programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, whether it's in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? So how do you get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But before we go further, there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution, looking for ways to make more tangible processes, which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases and more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, both in appearance and function, various automated robotic machines and systems commonly used in commercial manufacturing. Now, before we look at each of these models, let me provide you with just a little bit of background. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, with the Fischertechnik system, it was created with more of an engineering mindset. The core building block in the Fischertechnik system is designed to enable attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts in the Fischertechnik system are designed to slide together and lock in place, and the hundreds of different parts available also help to address very specific design needs. The Fischertechnik system was created back in the 1960s by German inventor Artur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction. They also produced numerous components used in the automobile assembly method, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of the Fischertechnik sets, whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by Fischertechnik for the education sector are subject-specific sets focusing on different STEM-related skill areas such as mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique Fischertechnik system and then perform various experiments which allow them to explore and understand aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error experimentation and research. Now, the line of Fischertechnik simulation solutions, which are the focus of today's presentation, are something much different. The line consists not of kits, but again of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line include conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, high-bay storage warehouse systems, and many more. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, a vacuum gripper robot, a high-bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, all working together as one self-contained material cycle. And to the one panelist who just had a question, yes, we will be sharing this presentation in a recorded form later. Now, before we look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using fischertechnik solutions. Now, I do apologize in advance as if the first few points are things I mentioned earlier, but I think in each case it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in the programming of PLC-focused learning environment. Advantage 2. The models, once again, are designed to realistically replicate, both in appearance and function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Now, because the models are compact, in most cases tabletop sized, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Another factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model, with one exception which I will address later, is currently available in 2 different versions. The first version is a 24-volt version, which is designed for use with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or others, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language, such as the ones you see listed on the screen now. Now, please note that with the 24-volt versions, no PLC is included, and all programming and all programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users, or for those users teaching or exploring industrial processes involving PLC programming. On the other hand, for non-industrial users and educators not versed in or familiar with PLC programming, there are also 9-volt versions of each model available. Now, these 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controllers, the Robotics TXT controller, and each controller is pre-programmed using fischertechnik's own RoboPro graphic programming software. Now, the only additional component required with the 9-volt versions will be the addition of 1 or more 120-volt power adapters as specified with each model. I will address this as we look at the various models so you'll know what needs what. But otherwise, in most cases, these should be ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adopted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik also offers a special IoT-focused version of the factory simulation designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. Now here, the model is designed to be both controlled and monitored from a special web-based dashboard. We'll of course discuss this in more detail later in the presentation. And finally, fischertechnik simulation models are cost-effective. While I won't get into naming names, I will say that if any of you have looked into other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that the entry point for many of these products could easily be $20,000 to $30,000 or more. Fischer-Technic simulation solutions, on the other hand, are only a fraction of that price, and as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's look at each of the models which are available. First up is the vacuum gripper robot. Now, as you will soon see, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you see on your screen in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches with an approximate weight of about 7 pounds. Now, the 24-volt versions of this model, as well as the other 24-volt versions we will look at, each have a relay board for motor polarity reversal and both a multi-pin connector with 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connectors for all inputs and outputs. Now again, the 24-volt version of this model, as with all of the 24-volt versions we will look at, will require you to provide the PLC and the programming. Now the 9-volt version, which is the version that you actually see in this video, will once again come wired to the fischertechnik robotic TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single power adapter will be required. I will also mention that all of the models we will look at today, the specs are also detailed in the products listing found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next, we have the automated high bay warehouse. The model features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will note that this model is a favorite among educators I know who are teaching programming because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step, which will of course require its own specific coding. Now, the dimensions for this model are approximately 19 by 28.5 by 15 inches with a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector with 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connectors for all inputs and outputs. Again, you will need to provide your own PLC and programming. The 9-volt version again is pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is required. Now, the next model, as you see already on your screen, is the multi-processing station with oven simulation. And it should start up in just a second. Just catching a second here. Excuse me for the slight technical malfunction here. I think we're good to go now. Once again, we're looking at the multi-processing station with the oven. Now, the model you're going to see features a furnace simulation with a pneumatic sliding door. Now, there's a downstream processing station with the pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Now, components used on this model include 4 mini motors, 6 push-button limit switches, 2 phototransistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches with a weight of about 11 pounds. Now again, this model is available in both 24-volt versions for use with the PLC of your choice, and the 9-volt version in this case is connected to 2 robotics TXT controllers. So in this case, you're going to need 2 power adapters, which will be required for all the operations. We'll just let this play for a minute. Now, the next model in our progression is the sorting line with color detection. And we don't need the audio here. So we will kill that. Now, this simulation features a system for detecting workpieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Now, components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this particular model are approximately 20 by 14 by 12 inches with a weight of about 10 pounds. Now, as with the models we've looked at before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you need to provide the PLC and the programming. The 9-volt version, once again, comes pre-wired to a pre-programmed TXT controller, and so only 1 power adapter is going to be required with this. Now, the next model is the factory simulation, which combines the 4 models that we've just reviewed here: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, all of which are combined into one self-contained material cycle. Now, the cycle works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot and then moved to the multi-processing station with oven. After the work piece has been processed by this machine, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here. What I do want to discuss are the dimensions of this model as a whole. Now, as it again combines 4 individual models into one cycle, it has a much larger footprint. And in this case, it's approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that the factory simulation models tend to be in very high demand, so please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Now, a few other things to note. First, this is again available in both 24-volt and 9-volt versions. Now, in this instance, the 9-volt version is wired to 5 robotics TXT controllers. As such, it's going to require 3 power adapters because of the way the controllers are wired together. And as always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required. Again, each station on the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with a pushing connector for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed, who will need to transport the model or who would like to protect it when it's not in use. Now, the travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. Now, the lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches with a weight of approximately 53 pounds. Please note, though, that even when using the travel case, these models will still need to be shipped flat. The next model is a basic conveyor belt. Now, this is a transport belt with a length of 275 millimeters that is used to transport workpieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Now, components on this model include an XS motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches with a weight of under 2 pounds. Now, as I mentioned before, this is available in both a 24-volt version, as you see here, and also 9-volt versions connected to the robotics TXT controller as shown here. One 120-volt power adapter is again required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. This feature is essentially the same conveyor as we just looked at, except this time with the machining station built in. Components on this model include 2 XS motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches with a weight of about 3.5 pounds. Again, it's available in both the 24-volt variation as shown in this photo and in the 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. Now, this model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts I just mentioned, 8 XS motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches with a weight of about 8 pounds. Again, it's available in both the 24-volt version for use with PLC as shown here, and a 9-volt version wired to the pre-programmed robotics TXT controllers, 2 of them as you see here, and requiring in this case 1 power adapter. Next is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. Hang on a second here. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters. And axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of this model are approximately 19 by 16 by 9 inches with a weight of about 6 pounds. Again, as with the other models we've looked at, this is available in both a 24-volt version for use with PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models, all of which again are available in both 24-volt versions and 9-volt versions. Now the next simulation model is designed to specifically address the topic of cloud-based monitoring and control. This is the Training Factory Industry 4.0 model. Now, this model was designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a large scale. Now, as the following video provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator here.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The 6 Fischertechnik TXT controllers control the learning factory. The controllers communicate with each other via standard MQTT protocol. The controller programs are written in C, C++, and the controllers arrive with the programs already loaded on them so that they can be used right away. The programs can be changed and customized. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. Views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The high bay warehouse is organized chaotically. There is no fixed space for a material to be stored. The system simply recognizes the next available space. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. Material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. FischerTechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Pretty impressive, I hope you'll agree. Now, just to kind of summarize some of what we've heard, the following topics can be addressed with the FischerTechnik Training Factory Industry 4.0 model. And I hope you'll ignore the delivery driver who's learning how to use his horn today. But anyway, going back. Some of the topics you can address with the FischerTechnik Training Factory Industry 4.0 include training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and material planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, the model incorporates many features not found in the models we've previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enable the positions of each piece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with each other. Now, as discussed, this model is currently only available in a 9-volt version, with the control facilitated through the use of, in this case, 6 robotics TXT controllers. Now, unlike all other 9-volt versions we've looked at previously today, these are programmed not using RoboPro, but again, instead using C, C++. Now again, all of the programming is preloaded so that once connection to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF that you saw them looking at in the video, once you have that, you should be able to get started quickly. Now, dimensions for this model are approximately 39 by 31 by 16 inches, and the weight is approximately 53 pounds. Now, I will note that this 9-volt version will require the addition of 3 120-volt power adapters and the ability to access the internet, as well as, of course, a tablet or a device for accessing the cloud-based dashboard. Now, as with the 2 factory simulation models we discussed previously, we recommend the travel case to help protect your model during transport or storage. Now, this of course begs the question, so what about a 24-volt version? Well, the answer is that version is expected to be formally announced very shortly. The original plan was that we would have this available for ordering by late spring, but with the disruptions caused by the COVID-19 crisis pushing everything back somewhat, we're hopeful to get an announcement by later this summer. And that essentially is the Training Factory Industry 4.0 model. Of course, you're probably wondering how much these models cost. Let's take a quick review of each option we've looked at, along with the pricing for each of them. First, we'll start with the vacuum gripper robot. As you'll see, the 24-volt version, with the part number there, is $8.99 each, and the 9-volt version is $11.99. You will note that in most cases, the 9-volt versions are going to be more reasonably priced than the 24-volt version, and that is, of course, because the 9-volt versions all come, once again, pre-wired to the controllers, where with the 24-volt versions, you will be supplying your own PLC for the control systems. Next, the automated high bay warehouse. The 24-volt version has a list price of $1,035. The 9-volt version has a list price of $1,319. The multi-processing station with oven, once again, the 24-volt version is $989, and the 9-volt version is $1,479. The sorting line with color detection has a 24-volt price of $819 and a 9-volt price of $1,129. The full factory simulation in the 24-volt version, it is $3,729 list, and the 9-volt version is $5,239 list. The conveyor belt, $220 for the 24-volt version, and $519 for the fully wired pre-programmed 9-volt version. The punching machine with conveyor belt, the 24-volt version is $289 each, and the 9-volt version with the controller is $599. The 3D or 3-axis robot, in the 24-volt version, it is $829 each. The 9-volt version, once again pre-wired to the TXT controller, is $1,099 each. The indexed line with 2 machining stations in the 24-volt version is $879, and in the 9-volt version is $1,399. And for exploring, teaching, or demonstrating cloud-based monitoring and control of automated systems, there is the Training Factory Industry 4.0. Again, this model is currently available only in the 9-volt version, with the 24-volt version to be released soon. And as you see, the 9-volt version has a price of $6,495 list, and the 24-volt version is still to be determined. And once again, we should announce all of those details later this summer. Now, as I've also mentioned at various points during the presentation, the 9-volt models will require 120-volt power adapters for operation. Now, these are available at a cost of $12.99 each. The 24-volt versions, again, as I have mentioned numerous times throughout the presentation, will require the end user to have or obtain their own choice of PLC and to provide all programming required, all power supplies, and any other hardware required. And once again, if you wish to purchase one of the aluminum and plastic travel cases for either version of the factory simulation or for the Training Factory Industry 4.0 model, in either the current 9-volt version or the forthcoming 24-volt version, the case to fit all of these models is available at a cost of $1,000 each. So at this point, I will open up the floor for questions where I will actually look at these chat windows and what have you. So let me just move things around a little bit here, get my windows all open. Is there curriculum with this? Asks Sam. No, there are not specific curriculum elements with these. I will say that with the factory simulation models, whether it be the 9-volt, 24-volt standard versions, or with this Training Factory Industry 4.0 model, there are materials that come with it that will outline some exercises you can do and things of that nature, different teaching material, but I won't go so far as to call it full curriculum. If you need to see examples of that, of course, you can contact your dedicated educational representative, and I will make sure that they can share examples of that with you. If you would like, you could also email me directly, my email being lancez, L-A-N-C-E-Z, @studica.com, and I will be happy to provide that to you directly as well, or to anyone else on this call presentation. In the logo, is there any inference to being a Christian-based organization? Well, while I cannot speak to the beliefs of all the employees of FischerTechnik, no, actually, they just chose it because of the fish. It's a German company, and I don't think that came up as much at first. But no, it's not. Nothing against it. It's just not intentionally meant to be Christian. So, non-denominational in this case. Are 9-volt versions easily adaptable to 24-volt PLCs? No. You would either get the 9-volt version if you weren't going to use PLCs, or you get the 24-volt versions if you were using PLCs. While I wouldn't say that you couldn't do it, it would also require that you switch out a number of the components. Like when I mentioned things like the motors, you would have to switch the 9-volt versions, whether it be encoder motors or even some of the basic excess motors that are used, you would have to switch those out for the 24-volt versions. Same for compressors, same for solenoid valves and what have you. It would all in all be a lot of work. We also do not have any kind of assistance we would offer you in doing that. So if you did, for whatever reason, choose to do that on your own, that is you all on your own. Do you have microcontroller-based modules? Just what you've seen right now, nothing else at this time. Not to say they won't change. Let me see if there's anything else I'm missing here. Okay, Dean's other question was about the recording. I know these are high quality, but can we get spare parts? Is there a list? I don't have a list I could formally send you just once again to these models, but I will tell you, if you go to our webpage, the studica.com page, and you go to the FischerTechnik listing, we do sell all of the spare parts, whether you need them to add on to models you might build or just to switch out on these models as things wear out, whether it be blocks, encoder motors, photo transistors, any of the parts that you've seen for these models. Yes, you can purchase them on our website in whatever quantity you choose or need, one or more. Is there any licensing fee for student seats per lab? No. With this product, whether we're talking about the models themselves, no. There's no licensing fee that applies. You buy the model, you use it however you're going to use it. That won't be an issue. I'm going to see, I see someone asking about my email address, so I'm going to type it into the chat window here. There you go, Lancez, Lancez @studica.com. From Dean Coe, once again, are these pre-programmed? Referring to any of the 9-volt versions we've looked at, yes. All of the 9-volt versions that are non-PLC based are pre-programmed, and essentially when you get any of the 9-volt versions and you get the power adapters as required, whether it's 1, 3, or whatever is mentioned here, basically then you're good to go. There shouldn't be any issue with that. So once again, they are all pre-programmed. You could also buy the RoboPro programming software separately. That is available on our website. I'm not going to quote you because I don't remember the exact price, but I want to say a single user license of RoboPro is currently under $40 on our website. A classroom, or not a classroom, I should say a school site license of RoboPro should be available on our website for under $130, and that is a school single site unlimited site license. So no matter how many computers you had in that school, as long as it's a single site, you could use that RoboPro site license. And again, those are available on our website. Is there an additional cost for the cloud-based dashboard? No, there is not, Sam. The cloud-based dashboard access comes when you actually purchase that. That's going to be all included, and once again, that's going to be in the documentation that comes with the Training Factory Industry 4.0. Once again, do note that that is the only model that does have a cloud-based dashboard is the Training Factory Industry 4.0. Just the 9-volt version is currently available, but again, we should have the 24-volt version with PLCs later this summer. Let's see what I might have missed here. Does RoboPro use ladder logic method for programming? Essentially, RoboPro is just graphic programming software using a flowchart style design. I personally, Dean, am not familiar enough with all of the specifics of the different PLC programming languages to say what it's going to be most similar to. I apologize for that. But I will say that essentially it's going to be RoboPro is a flowchart style design. So you basically, once again, you have the icons, you link them, and then you can, branch off of those and have, if this happens, then do this, and if that happens, proceed here. So you can make those as elaborate or as simplified as you need to be. We do have, I could probably send you examples of what RoboPro looks like if you'd like to. And once again, if you use my email address and just send me an email, I'll send you some screen captures of what RoboPro itself looks like. Let me see. I'm going to go back here to the top and just see if I've missed anything. And I do appreciate all the questions. Let's see here. I think I don't see anything open in the question and answer window. I think I see one new message. I'll see that in a second. Licensing per lab. Once again, it's all included. There's no fees. You can alter the programming. Yes, Dean. You can alter the programming on the 9-volt versions using the RoboPro. So for the 9-volt robotic arm, we can program the RoboPro for other functions. You could program any of these models to differ from how they're programmed. Once again, if you get the 9-volt versions using the RoboPro programming software. And the software itself does include a help section right inside the software, right at the toolbar at the top of the RoboPro software, has a section where it's essentially kind of a tutorial on using it. Also, if anyone on this presentation does want some of the materials that we make available for other programs, the educational programs, such as if you heard me mention the project-based learning programs that we do for middle and high schools at the beginning of the program, we include sections in there on becoming familiar with programming with RoboPro. And so if any attendees of this call would like access to that material and you'd need to use the 9-volt version with RoboPro, I'd be happy to send you sections from the curriculum that do refer to that. So that's not an issue. Any other questions? I do appreciate this. Let's see. Sam, I'm happy that you're happy with this. That's great to hear. For anybody wondering, I do know that we just got 2 of the Training Factory Industry 4.0 models in stock as of yesterday. We have been cleaned out, but I just took them off the pallet. We have 2 of those. We have 2 travel cases in stock now. Do know they will go soon, but I do have 2 that do not have a name on them yet. So if you talk to your representatives about that, you can probably get an order in quickly. And of course, we will have more coming all the time. But as I said, we do have 2 as of this afternoon. So I'm glad that all of you could make the time to attend today. If you do have any further questions, as Christy had before and as I typed in, I will type it in again, my email address. Please feel free to contact me directly with anything that might come up, and I will be happy to help you out. So let me just go back to the live show here. Taking the next step. So if you would like to request a full color brochure and current pricing, which you did see on the screen, but of course we'd send you a price list and a full color brochure. If you'd like to ask other questions directly, if you'd like to request a quote, if you'd like to speak with your dedicated educational representative, depending on what state you're in, there's a different representative. To do any of those things, you can call us. Studica US is 888-561-7521. If you'd like to email us, if it's a general inquiry, you can email info@studica.com about any of the fischertechnik models you saw today, any of the other fischertechnik solutions. If you have any questions on anything we talked about today specifically and you want to get me directly to answer them, I'd be happy to. Lance.Zurich, I also use the Lance Z, but lance.zurich@studica.com, lance.zurek@studica.com, or Lance Z, LANCEZ@studica.com. Both will work, both will get to me. So on that note, I'd like to thank everyone once again for taking the time to attend. As Christy probably mentioned in the chat window, we will be emailing out a link to the recording of this, so if you would like to share it or review anything, and once again, if you have any questions at all, please feel free to reach out to me. So on that note, stay safe, stay well, and thank you for attending. Take care.